When you create a script in Unity, you will come across many different methods. But there are five methods that you will see again and again when working with Unity scripts. These are awake, start, update, fixed update, and late update. These are commonly used Unity lifecycle methods, and each one has a different purpose. But the confusing part is, when does each method run? What exactly does each one do? And most importantly, where should we use each one? So in this video, I am going to explain all five methods in very simple terms with real examples so you can understand exactly when and why to use them. Let's start with the first one. The first method is awake. Awake is one of the first lifecycle methods called when a game object is initialized. Think of awake as the preparation stage. Imagine you are starting a game. Before the actual gameplay begins, your player needs to prepare everything it needs. For example, the player might need a reference to its rigid body, animator, audio source, or another component. This is where awake is commonly useful. You can think of it like this. Before we start the game, let me prepare everything I need. For example, imagine you have a player. When the player is created, awake can be used to find and prepare the components that the player will need later. So awake is mainly used for initial setup, getting component references, setting initial values, preparing the object before gameplay begins. An easy way to remember it is awake equal to prepare. Next, we have start. Start is also called automatically by Unity. Start happens before the first frame of gameplay. So what is the difference between awake and start? Think about it like preparing for a trip. Awake is when you pack your bag and prepare everything you need. Start is when you are ready and the trip actually begins. That is a simple way to understand the difference. Start is commonly used for things that need to happen when gameplay is about to begin. For example, you might use start to set the player's starting health, set up a starting position, initialize game values, start a timer, set up something that depends on other objects being ready. So awake is prepare everything. Then start is okay, let's begin. Now let's talk about the most commonly used method, update. Update is called once every rendered frame. For example, if your game is running at around 60 frames per second, update can run around 60 times per second. And if your game is running at 30 frames per second, update can run around 30 times per second. So update is perfect for things that need to be checked or changed every frame. For example, imagine you are controlling a player. Every frame the game needs to ask, is the player pressing left? Is the player pressing right? Is the player trying to jump? This type of input checking is commonly handled in update. Update is also useful for things like player input, non-physics movement, rotations, timers, checking conditions, general gameplay logic, updating UI or other frame-based behavior. Think of update as a game's regular frame-by-frame thinking. Every frame Unity comes back and says what should happen now. That is why update is used so often. But there is one important warning. Don't put everything inside update. A beginner might think if update runs every frame, it just put all my code there. But that's not a good habit. Different types of work have different lifecycle methods, and that is where fixed update comes in. Fixed update is mainly associated with physics. The important difference between update and fixed update is how often they run. Update depends on game's frame rate. The frame rate can change. Maybe the game is running at 60 FPS, then it drops to 40 FPS, then it goes back to 60 FPS. So the time between update calls can change. But physics need more consistent time step. That is why Unity has fixed update. Fixed update runs using a fixed time interval, which makes it suitable for physics calculations. For example, imagine you have a ball with a rigid body. You want to push the ball forward, or you want to apply gravity, or you want to make the physics based object move. These are the kinds of things that are normally handled through the physics system and are commonly placed in fixed update. So you can remember, update is equal to frame based logic, fixed update is equal to physics based logic. Now we have the final method, late update. As the name suggests, late update happens later. More specifically, it runs after the normal update phase for that frame. So why do we need it? Let's imagine a third person game. You have a player and a camera. The player moves first. After the player has moved, you want the camera to follow the player's new position. This is a perfect example of where late update can be useful. You can think of it like this. Update, the player moves. Late update, know that the player has moved, I will update the camera. This is why late update is commonly used for camera follow systems, camera positioning, follow objects, things that depend on another object's update position, some visual adjustment that should happen after normal gameplay logic. So the easy way to remember it is late update is equal to do it after update. But don't think that these methods always runs in exactly this simple sequence every frame. Awake and start are part of the initialization process. After that, update and fixed update operate on different timing systems. Update is connected to the rendered frames. Fixed update runs at a fixed physics time step. Then late update happens after the update phase for that frame. So the important thing isn't memorizing a simple straight line. The important thing is understanding what each method is designed for. So now, when you open Unity script and see awake, start, update, fixed update, and late update, you don't have to think of them as a random methods. Each one has a specific purpose. If you found this explanation useful, just stay tuned to our channel.